Welcome to the introduction of the black hole. I'm Lee Xiaoqi and this is my partner Dibashni Bharatharaju.
Our video today will be based on the formation of the black hole and theories from famous physicists like Stephen Hawking and J.J. Thomson.
So what is a black hole? A black hole is an object with a powerful gravity that swallows in anything that comes near it due to its incredibly strong gravitational pull. Not even light can escape it.
A black hole is formed when any object reaches a critical density which gravity causes it to collapse to almost an infinitely small pinpoint. The black hole's mass is concentrated to an almost infinite density called a singularity.
The formation of the black hole also depends on the gravity to radiation ratio a star possesses. This short clip will explain it all.
As long as there is fusion in the core, a star remains stable enough. But for stars with way more mass than our own Sun, the heat and pressure at the core allow them to fuse heavier elements until they reach iron. Unlike all the elements that went before, the fusion process that creates iron doesn't generate any energy. Iron builds up at the center of the star until it reaches a critical amount, and the balance between radiation and gravity is suddenly broken. The core collapses. Within a fraction of a second, the star implodes, moving at about a quarter of the speed of light, feeding even more mass into the core. It's at this very moment that all the heavier elements in the universe are created as the star dies in a supernova explosion. This produces either a neutron star, or if the star is massive enough, the entire mass of the core collapses into a black hole.
Due to its strong gravity, it crashes normal space-time out of existence. Similar to the law of universal gravitation and the Coulomb's law, as the distance from the singularity increases, the gravitational influence lessens.
A lot of people assume that once you're trapped in a black hole, it isn't possible to escape, but that isn't true. At a certain distance, depending on the singularity's mass, the speed needed to escape the black hole equals to the speed of light.
The distance marks the black hole's horizon, which is like its surface. Anything that passes through the horizon is trapped inside the black hole. Black holes come in several varieties depending on the mass.
Things that are pulled into the black hole falls into what is known as the dark abyss. Humans still aren't able to identify where the black hole leads to. We have sent artificial satellites, which are human-made satellites, to orbit around them to learn the behavior and gravity readings of a black hole.
Knowing that massive stars have a chance of collapsing into a black hole as well, it made humans wonder whether the Sun will ever face the same fate. Here is a short video that explains and reveals the answer.
Falling in love is just like falling in a black hole. Time goes slow for you, but it's the same for everyone else. But what are black holes, and how did they get here? A black hole is a region in space with a gravitational field so strong that no matter or even radiation can escape. To understand how black holes are formed, we must first look at how stars stay puffed up against their own gravity. So in any living star, there's this constant tug of war between its gravity pulling the matter in and the internal pressure pushing it out. This means the star will neither expand nor collapse. This is the case for our Sun at the moment. But when the star runs out of nuclear fuel, its internal pressure loses against its own gravity and causes the star to collapse. Now there's another form of pressure which slows down or stops the collapse of the star. This is called the electron degenerate pressure. To put it in simple words, the collapse squeezes the electrons in a very small space, and the more it squeezes, the more pressure is exerted. In smaller stars like our Sun, once the nuclear fuel is exhausted, this electron degenerate pressure becomes strong enough to stop the collapse. This turns the star into a small, dense, shining hot object called a white dwarf. So our Sun can never become a black hole. However, it can collapse to become a white dwarf and eventually cool down to become a black dwarf.
Believe it or not, black holes do disappear. But how?
Studies have showed that it will lose all of its mass and shrink as the particles escape from it. This in turn would increase the emission rate of particles, and further mass is lost, resulting in the disappearance of the black hole.
So that's how it works. However, what emerges from the black hole is just tiny random objects that has no relation to what fell in.
This is because black holes can emit any collection of particles such as thermal radiation. But the good news is, our beloved Earth is unlikely to become a black hole. Human knowledge on black holes may appear impressive, but it does not actually contain all the explanation for a black hole.
A black hole is the most mysterious and aggravating subject to humans. This is because we want to know more, how it works and how we can apply it to technology.
New technology that engineers the workings of a black hole could possibly become a breakthrough to end pollution on Earth, as we could get rid of toxic substances to a place far away and even deteriorate these substances.
Not only that, with these new technologies to improve pollution, it will better human health around the world, as many diseases stem from the contaminated atmosphere.
However, at this moment of our lives, black holes greatly influence scientists who study about them. With the knowledge obtained, it may inspire inventions, innovations, and ideas from other people or even themselves.
Stephen Hawking, one of the most respected men on Earth today, has theorized about a black hole, from being burnt to its singularity to the exposure of time traveling. He believes that learning the truth about black holes is a step closer to creating a better future for everyone on Earth. With many aspiring advantages comes just as spiteful disadvantages, like
Black holes can account for the end of the world.
black holes can create serious weather fluctuations on Earth.
Black holes can destroy the universe.
Black holes, when coming to the end of its lifetime, will blow up in the form of thousands of nuclear bombs detonating at the same
Black
time.
holes, if ever created on Earth, will cause an imbalance of nature, as the composition of air will be topsy-turvy.
Okay, there are so many more effects that black holes have on Earth and society. An important lesson to keep in mind when dealing with the unknown is
To always judge if it's better left unknown.
people always suggest that pollution and the expansion of the construction industry will mark the end of Earth. However, black holes do not always come up because people think it is so far away that it can't hurt Earth. However, black holes can create catastrophic turmoils if it came close to any planet. However, we're just going to focus on Earth because that's what society cares about. This video is about the visualization of the end of the world in the perspective of the black hole.
If a black hole approached Earth, all that gravity would rip asteroids from their orbits and hurl them toward our planet. The Earth's surface would become an inferno. It would be the beginning of the end. First, it would swallow up the atmosphere, then the planet itself. Destroying an entire solar system is nothing to a black hole. But it's more than just a big, empty, sucking piece of space. It's incredibly heavy. To get an idea just how heavy and dense a black hole is, imagine the Earth. Now, start to crush it. And keep crushing until it's packed so tight, even the atoms themselves collapse. When the Earth crushes down to just 2 inches across, that's the density of a black hole. It would be the size of a golf ball, yet weigh the same as the Earth, with the same amount of gravity.
This tends to prove that size does not matter when it comes to power.
So in the end, black holes are a part of nature and they need to be respected even though they may tear our world apart, like literally.
Knowing about where a black hole leads to would be an amazing discovery for humans on Earth. However, applying it would be the biggest debate and worry.
That wraps up for our introduction of black holes to you lovely viewers!
Thank you for watching the video. We hope you enjoyed it. And Hakuna Matata, because you know what that means. Oh no, we left!
No, yeah,
Ah, the answer.
Okay, again, let's like watch it again.